Dive into 79 must-know concepts necessary for acing the Tool and Die Maker Red Seal license exam. Access comprehensive preparation materials at www.cannycollege.com to ensure you are fully prepared for success. 1. Maintains a safe work environment. Ensures that the work area is free from hazards and follows safety protocols to prevent accidents and injuries during tool and die making processes. 2. Uses personal protective equipment, PPE, and safety equipment. Wears appropriate PPE such as safety glasses, gloves, ear protection, and steel-toed boots when operating machinery to protect oneself from potential workplace hazards. 3. Uses hoisting and lifting equipment. Utilizes equipment like cranes, forklifts, or hoists to move heavy materials, dies, and tools safely and efficiently in the workshop. 4. Maintains machine tools and tooling. Regularly cleans, inspects, and performs maintenance on machine tools, dies, and cutting tools to ensure they are in good working condition and produce accurate results. 5. Interprets drawings, specifications, and applications. Understands technical drawings, engineering specifications, and project requirements to plan and execute tool and die-making processes effectively. 6. Plan project activities. Develop a detailed plan outlining the sequence of tasks, timelines, and resources needed to complete tool and die-making projects efficiently and accurately. 7. Performs bench work. Uses hand tools, manual equipment, and precision measuring instruments to shape, finish, and assemble tool and die components at a workbench. 8. Performs layout, marks, measures, and lays out reference points, dimensions, and workpiece features according to engineering drawings and design specifications. 9. Marks material for identification, labels and marks materials, components, and workpieces with identification codes, part numbers, or instructions to track and identify them during production processes. 10. Inspect workpieces, conducts visual inspections and measurements on finished workpieces to verify accuracy, dimensions, and surface quality, ensuring they meet design requirements. 11. Finishes workpiece, applies cutting, grinding, polishing, or coating techniques to achieve the desired surface finish, texture, and dimensional accuracy on workpieces. 12. Plans and prepares for machine tool operations. Organizes tools, materials, and work instructions before operating machine tools, ensuring proper setup and safety precautions are in place. 13. Plans machining sequence, determines the order in which machining operations will be performed on a workpiece to achieve the desired shape, dimensions, and features efficiently. 14. Establishes workpiece datum, defines a reference point or plane on the workpiece from which all measurements and machining operations will be based, ensuring consistent accuracy and alignment. 15. Set up work holding devices in machine tools. Installs and secures clamps, vices, fixtures, or chucks on machine tools to hold and position the workpiece during machining operations securely. 16. Set up machine tooling and accessories. Mounts cutting tools, drills, and other accessories on machine tools, adjust tool settings, and verify alignment to prepare for machining operations. 17. Set up the workpiece in the machine tool. Position and align the workpiece securely in the machine tool, ensuring proper orientation and fixturing for accurate and stable machining. 18. Select speeds and feeds of machine tools. Determines the optimal cutting speeds, tool feeds, and machining parameters based on material properties, tooling, and cutting conditions to achieve efficient and precise cutting operations. 19. Performs hole making and finishing operations. Drills, reams, or taps holes, and performs deburring, chamfering, or other finishing operations to complete workpiece features with precision and quality. He turns surfaces using a lathe, uses a lathe machine to rotate and shape cylindrical workpieces by cutting metal materials with turning techniques, achieving accurate dimensions and smooth finishes. 21. Faces surfaces using the milling machine. Uses a milling machine to trim, flatten, or square workpiece surfaces with milling cutters, achieving flat and perpendicular surfaces for precise machining operations. 22. Performs parting, grooving, and knurling using the lathe. Utilizes a lathe machine to cut grooves, part off workpieces, or create textured patterns, knurling on cylindrical surfaces for various tool and die-making applications. 23. Cuts internal and external threads using the lathe. Utilizes a lathe machine to cut precise internal and external threads on workpieces using threading tools and techniques to create threaded components such as screws, bolts, or other threaded parts. 4. Performs profiling, pocketing, and slotting using the milling machine. Utilizes a milling machine to shape, cut pockets, and create slots in workpieces using various cutting tools and milling techniques to produce complex profiles, features, and geometries accurately. 25. Saws straight and angle cuts. Uses sawing equipment such as bandsaws or circular saws to make straight or angled cuts on workpieces with precision, ensuring accurate dimensions and clean cutting edges in tool and die-making processes. 26. Cuts irregular shapes. Utilizes cutting tools, saws, or machining processes to cut irregular or complex shapes in workpieces efficiently, accurately, and according to design requirements for tool and die components. 27. Mounts grinding wheel, fixes and secures grinding wheels on grinding machines to prepare for surface grinding, sharpening, or finishing operations on workpieces using abrasive materials to achieve precision and accuracy. 8. Grinds flat surfaces. Utilizes surface grinding machines to remove material from flat surfaces of workpieces, achieving flatness, parallelism, and surface finish requirements in tool and die-making applications. 29. Grinds profiles and tapered surfaces. Uses profile grinding techniques and equipment to create specific shapes, contours, or tapered surfaces on workpieces with precision, accuracy, and consistent surface finish for tool and die components. 30. Performs basic CNC programming. Creates simple CNC programs using computer-aided design, CAD, software, or CNC programming systems to generate toolpaths, machining sequences, and commands for CNC machines to automate manufacturing processes. 31. Inputs program data into control memory. Enters and uploads CNC program data, tooling parameters, and machining instructions into the control memory of CNC machines to execute programmed operations and commands during tool and die-making processes. 32. Set up workpiece datum, establishes reference points, coordinates, or planes on the workpiece, from which machining operations and measurements will be based, ensuring consistency, accuracy, and alignment in tool and die-making setups. 3. Verifies programs, checks and validates CNC program codes, toolpaths, and machining sequences against design specifications, workpiece requirements, and machining parameters to confirm accurate and error-free programming. 34. Monitors machining processes. Observes, supervises, and oversees machining operations and CNC processes to ensure they run smoothly, perform as expected, and produce workpieces that meet quality standards and dimensional tolerances in tool and die making. 35. Operates electrical discharge machines, EDM. Utilizes EDM equipment to create intricate shapes, contours, or cavities in workpieces by using electrical discharge sparks to remove material accurately in tool and die-making applications. 36. Determines flushing methods, selects and implements appropriate flushing methods or techniques during EDM operations to remove debris, maintain dielectric fluid flow, and optimize material removal rates in electrical discharge machining processes. 7. Sets cutting conditions, determines and adjusts cutting parameters, such as cutting speed, feed rate, depth of cut, and tooling conditions based on material properties, tooling type, and machining requirements to achieve efficient and effective cutting operations in tool and die making. 7. Develop prototype. Create a preliminary model or sample of a tool or die component design to test functionality, fit, and performance before full-scale production. 39. Select prototyping technique and materials. Choose appropriate methods and materials for prototyping based on design requirements, feasibility, and cost-effectiveness to create a functional representation of the final product. 40. Fabricate prototype components. Manufacture individual parts or components of a prototype using machining, cutting, forming, or additive manufacturing processes to build a physical representation of the design. 41. Assemble prototype components. Integrate individual prototype parts or components according to the design specifications, ensuring proper fit, alignment, and functionality in the assembled prototype. 42. Prove out prototypes. Test and validate the functionality, performance, and precision of the prototype through trials, measurements, and evaluations to verify that it meets design requirements and functions as intended. 43. Inspect prototype. Conduct an inspection and assessment of the prototype's quality, dimensions, tolerances, and features to ensure that it meets design specifications and performance expectations. 44. Evaluate the function of the prototype. Assess the operation, reliability, and efficiency of the prototype in real-world conditions to determine its suitability for the intended application and identify any necessary design improvements. 5. Resolve malfunction of the prototype. Identify and address any issues, malfunctions, or deficiencies in the prototype through troubleshooting, adjustments, or modifications to optimize its performance and functionality. 46. Heat treatment, a process of heating and cooling metal materials to alter their physical and mechanical properties, such as hardness, strength, toughness, or ductility to improve their performance characteristics. 47. Heat treats materials. Subject metal materials to controlled heating and cooling cycles to achieve specific material properties, such as hardness, strength, or stress relief through processes like annealing, tempering, hardening, or normalizing. 48. Select heat treating process. Choose the appropriate heat treatment method based on the desired material properties and the specific requirements of the tool and die components, such as quenching, annealing, tempering, or carburizing. 49. Harden materials. Increase the hardness of metal materials through heat treatment processes involving rapid cooling, quenching, to achieve a hardened surface layer for enhanced wear resistance and durability. The temper materials. Reduce the hardness and brittleness of hardened materials by reheating and then cooling them slowly, adjusting the internal structure to improve toughness, ductility, or machinability. 51. Anneal materials. Heat metal materials to high temperatures and then slowly cool them to relieve internal stresses, improve ductility, or refine grain structure, and prepare the material for subsequent machining or forming processes. 52. Normalize materials. Heat metal materials to a specific temperature and then air-cool to achieve uniform material properties, refine grain structure, relieve internal stresses, and improve the machinability of the material. 53. Carburize materials. Introduce carbon into the surface layer of metal materials through heat treatment to increase surface hardness, wear resistance, and case depth, enhancing the material's performance in applications requiring high wear resistance. 54. Test heat-treated materials. Verify the effectiveness of the heat treatment process by conducting material testing, such as hardness testing, Rockwell-Brinell, microstructural analysis, or mechanical property tests to ensure the desired material characteristics are achieved. 55. Perform visual inspection. Examine the surface finish, features, and overall quality of tools, dies, and components through visual inspection to identify defects, imperfections, or inconsistencies that may affect performance or functionality. 6. Perform hardness test. Measure the hardness of metal materials using hardness testing methods like Rockwell, Brinell, or Vickers to assess material strength, wear resistance, and suitability for specific application requirements. 57. Performs basic production tool design. Create preliminary designs or concepts for manufacturing tools, such as jigs, fixtures, or cutting tools to support production processes and improve efficiency. 58. Identifies production tool requirements. Identify the specific tools, equipment, or machinery needed for manufacturing processes based on project requirements, material characteristics, and production specifications. 59. Prepare shop sketches. Create detailed drawings or sketches of production tools, parts, or components to communicate design concepts, dimensions, and specifications for fabrication in the workshop. 60. Determines production tool material specifications and engineered components. Select appropriate materials, components, and engineered solutions for manufacturing tools based on factors like durability, wear resistance, heat resistance, and material compatibility. 61. Prepares information for drafting. Compile relevant data, measurements, and instructions to provide drafting personnel with the necessary information for creating detailed drawings and blueprints of production tools. 62. Fits and assembles production tools. Assemble and fit precision-manufactured components of production tools together according to design specifications, ensuring proper alignment and functionality. 63. Verifies dimensions of production tool components. Check and confirm the accuracy and alignment of dimensions, tolerances, and features of production tool components using precision measuring tools and inspection techniques. 64. Positions of production tool components. Arrange and position the individual components of production tools to ensure proper functioning, alignment, and interaction between parts during tool operation. Performs final assembly, complete the assembly process of production tools by integrating all components, fine-tuning adjustments, and verifying the readiness of the tools for operation. 6. Sets production tool timing, adjust and align the timing, control systems, or mechanical operations of production tools to ensure synchronization and precision in tool functions and movements. 67. Proves out production tools, test and validate the performance, accuracy, and functionality of production tools by running trials, simulations, and test runs to ensure that the tools meet production requirements. 68. Set up production tools, configure and prepare production tools for operation, including mounting machinery, adjusting settings, and calibrating tooling parameters for efficient and accurate manufacturing processes. 69. Verifies production part material. Confirm the material composition and quality of production parts by conducting material verification tests, inspections, or chemical analyses to ensure compliance with specifications. 70. Develop blank. Create initial outlines or templates known as blanks from which finished parts or components will be produced using shaping, cutting, or forming processes. 71. Cycles equipment with production tools. Operate machinery and equipment in conjunction with production tools to ensure proper functioning, tool alignment, and material processing during manufacturing cycles. 72. Evaluate production part. Inspect and assess the quality, dimensions, and surface finish of manufactured parts or components produced with production tools to ensure they meet design requirements and quality standards. 73. Check the production tool for damage. Inspect production tools for wear, damage, or defects that may affect performance or accuracy, and address any issues through repair, adjustment, or maintenance. 74. Modifies production tools to enhance productivity. Make necessary modifications or improvements to production tools to optimize performance, efficiency, or quality in manufacturing processes and achieve higher productivity. 75. Repairs and maintains production tools. Perform routine maintenance, repair, and upkeep of production tools to ensure they remain in optimal working condition. Extend their lifespan and prevent malfunctions during operation. 6. Identifies the condition of production tools. Evaluate and assess the condition, wear, and performance of production tools to determine maintenance needs, repair requirements, or potential upgrades to keep tools functioning effectively. 77. Identifies repair procedures. Determine the appropriate repair methods, procedures, or techniques needed to address issues, defects, or malfunctions in production tools and components to restore functionality and performance. 78. Adjust production tool components. Fine-tune, calibrate, or adjust production tool components such as cutting edges, fixtures, or controls to optimize tool performance, accuracy, and consistency in manufacturing processes. 9. Reconditions production tool components. Repair, refurbish, or restore production tool components to their original or near original condition by replacing parts, refinishing surfaces, or improving functionality and longevity for ongoing use in production operations.